எழுதலாம். First autocorrelation function. Autocorrelation function in general ACF, in short form ACF. What are all basics? R autocorrelation function will be defined like R small xx of tau, R xx of tau. Okay, so that is x of t replied with x of t minus tau, or otherwise with respect to this context we can use capital X also. Why? Because we are discussing about random process. Either autocorrelation formula is same, but where we are using, that is the important thing. As we are using in the random process, we'll put capital X. So this is capital X of t, then x of t minus tau, x of t minus tau. This is R x of t. Here I will get convolution formula. அதாவது at some time la நம்ம samples observe பண்றோம் with delay observe பண்றோம், அதாவது some other time, then we are doing the convolution operation. We are doing the convolution operation. This is exactly same as இதுல நீங்க என்ன பண்றீங்களோ அதே தான் இந்த ஃபார்முலாவிலையும் வரும். So here what I am doing, just I am multiplying x of t with x of t minus tau, then I am doing expectation. E means expectation, that means averaging. E means finding out the average value. x of t என்னன்னு தெரியும், x of t minus tau என்னன்னு தெரியும், ரெண்டுத்தையும் மல்டிப்ளை பண்ணிட்டு ஆவரேஜ் எடுங்க. அதுதான் வந்து ஆட்டோ கார்லேஷன். ஸோ கார்லேஷன் இருந்ததுன்னா இந்த வேல்யூ வந்து ரொம்ப பாசிட்டிவா இருக்கும், கார்லேஷன் இல்லைன்னா ஜீரோவா இருக்கும். இஃப் இட் இஸ் நெகட்டிவ்லி கார்லேட்டட் யூ வில் கெட் தி நெகட்டிவ் ஆன்சர். இதெல்லாம் வந்து லாஸ்ட் கிளாஸ்லேயே வந்து பார்த்தோம். ஓகே, நவ் சப்போஸ் இன் கேஸ் if this Rxx of tau is equal to 0, that means there is no correlation between these two. No correlation. Generally for random signal, correlation may be 0 also. We do not know. Okay, we have to analyze. Okay, correlation may be there, may not be there. For random signal, we cannot just by looking into the signal directly we cannot say. So autocorrelation may be 0 or may not be 0. But if it is 0, then there is no correlation. And another observation here is autocorrelation function is always function of tau. Autocorrelation, again here itself I mentioned Rxs of tau. That means the final answer really depends on tau. That means what is the time delay between the two observation. If time delay is 0, correlation may be more. If time delay is increasing, correlation may decrease. So the autocorrelation is always function of delay. அது நம்ம லாஸ்ட் கிளாஸ்லேயே வந்து பார்த்தோம். நெக்ஸ்ட், இன் கேஸ் if I am putting tau is equal to 0, okay, see delay I am trying to put 0. If tau is equal to 0, you can observe in the regular formula Rxx of 0 is equal to E of x of t and then x of t, E of x of t into x of t, then what happens? Then Rx of 0, okay, you are getting E of x of t into x of t. That means E of x of t square. That means Ex square of t, then average. Okay, so here what we are doing for that particular signal, we are just doing the square operation. Then we are applying expectation formula. So don't worry about that capital X or small x. Just we apply the formula. What we get, we know what is the expectation formula. Integration x square f of x dx is the generalized formula. Or otherwise, if you are in the time domain, okay, if you are in the time domain, just apply the time domain. So directly this E of x square of t, directly it will give the power of the signal. Directly this will give the power of the signal. You see what is the major challenge here? Say, see, x of t can be in general, it can be deterministic. X of t in general can be deterministic. That means we can write the mathematical form, or it may be random, If it is deterministic, you can find out the power in both domain. Power can be calculated in both domain. Say power, you can calculate power in t domain, and then you can calculate the power in frequency domain. Power in the frequency domain, you can calculate the power in any domain. But if it's random, okay, if it is random, mostly it's very difficult to calculate the power in time domain. You know, the power is always constant. Whether you are in the time domain or frequency domain, power of the signal is always same. So what we will do, just for a random signal, usually directly we cannot apply the formula in the time domain. Why? Because we do not know the, in general, mathematics of x of t. See here, I am drawing a random function. Here I cannot draw the mathematics for this function. So we cannot apply the time domain formula for the power, but we know what is the autocorrelation function. In that, just putting tau is equal to 0, directly we will get the power of the signal. So that is the main idea. That means this formula, autocorrelation, is applicable for both deterministic as well as random signal. Autocorrelation is allowed for both. Mainly autocorrelation we are discussing for random signal, but the same autocorrelation is applicable for deterministic signal also. In the last class itself we have seen. In the last class we have discussed about the sine and cos. Sine and cos is a deterministic signal. We know the mathematical form. So autocorrelation function is applicable for both deterministic as well as random. But if you want to find out the power of the random signal, the only way is you should know the autocorrelation function. In that, if you put tau is equal to 0, then directly we can calculate the power. That is the one of the advantage of the autocorrelation function in terms of random process. So for random signal, if you want to know the power, random signal power, you should know the autocorrelation function. Then in that, if you put 0, then you'll get the power of the random signal. That is the main idea of the autocorrelation function with respect to the power calculation. Okay, so this Rx of tau, we may also call it as a autocorrelation function at origin, ACF at origin. That means origin means at tau is equal to 0, the time delay is 0. Okay, Rx of 0, the another name we'll call it as a autocorrelation function at origin. So autocorrelation function at origin usually gives the power of the signal. Why? Because finally for the autocorrelation function also we will draw the diagram, say with respect to tau what is happening, with respect to the tau what is Rx of tau. Okay, see, usually the Rx of tau will be maximum at tau is equal to 0. I already told you autocorrelation function is function of tau. At tau is equal to 0, it will give the maximum value, that in turn is the power of the signal. See what I am telling, autocorrelation Rx of tau is usually the maximum value, maximum autocorrelation function, that in turn is the power of the signal. I already told you tau 0 means autocorrelation function will be very, very maximum. That is highly correlated. So autocorrelation origin will be always maximum, that in turn will give the power of the signal. Then if tau is not equal to 0, then it may decrease. Like this depending on tau. So this is tau Rx of tau nature. So autocorrelation function at origin usually give the power of the signal. Then ACF is maximum at tau is equal to 0. What is the another idea? Here itself we can write autocorrelation is function of tau. Then ACF autocorrelation function is maximum at tau is equal to 0. Autocorrelation function is maximum at tau is equal to 0. Autocorrelation function at origin is giving the power of the signal. Then for a deterministic signal, say the signal may be sinusoidal or cosinusoidal. For example, A cos 2 pi fct, then theta, or otherwise or A sine 2 pi fct, then theta. Okay, this is the deterministic signal. Okay, so for this deterministic signal, what is the autocorrelation function? For this deterministic signal, what is the autocorrelation function Rx of tau? Okay, the autocorrelation function formula is applicable for any signal. It may be deterministic signal or random signal. Okay, so now you apply the regular formula. What is the regular autocorrelation function formula? Rx of tau is equal to E of x of t. Okay, they are given in the deterministic signal. So simply take small x of t minus tau. You just apply this formula. then do the expectation, apply the expectation formula. Okay, as it is in the deterministic, you can easily apply the expectation formula. You know the mathematical form. Then the final answer Rxx of tau is equal to a square divided by 2 cos of 2 pi fc tau. Don't put t tau because autocorrelation is always function of tau. Autocorrelation is always function of tau. In this expression, only variable is tau. Tau may be 0 or maybe 1 or maybe minus 1. Tau can be anything. It can go from minus infinity to plus infinite. Fc is constant, a square, everything else is constant. The only variable is here tau. So tau is the variable. So now quickly we can verify this formula. Okay, they are telling autocorrelation at origin is giving the power of the signal. I have taken the deterministic signal, say sinusoidal or cosinusoidal signal. For both the signal, the power is a square by 2. For both the signal, the power is a square by 2. Then what is Rxx of 0? Rxx of 0. Once if you put tau is equal to 0, you'll get a square by 2. So that means we are proving the condition. Autocorrelation at origin is really giving the power of the signal. I already know what is the power of the signal in time domain itself because this is the usual signal. Okay, cosinusoidal and sinusoidal signal. So for that, the power is a square by 2. Okay, so this is giving the power of the signal, and also this is the maximum ACF. Maximum ACF. Why? Because at any point of time, cos will have the maximum value of 1. That means when you put tau is equal to 0, then only you will get 1. For all other value of tau, definitely it is going to be less than or equal to 1 only. So at tau is equal to 0, you are getting maximum ACF. That in turn is the power of the given signal. Power of the given signal.